In this video, we're going to talk about perpendicular bisectors of triangles and just how we will use the different properties about them. So perpendicular bisector, if you think of the name of it, perpendicular means that it will bisect, or that it will make a 90-degree angle with something, and a bisector means that it will also cut it in half. So it's a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. If you look at your picture on the far right, you can see that CP is the perpendicular bisector of segment AB. The two big properties you want to remember, or characteristics about this, is that it creates 90 degrees, so it's perpendicular and it goes through the midpoint. Next, we have the perpendicular bisector theorem, and that tells us that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Equidistant means it's equal distance, or that it's congruent distances. In our picture again, CP is the perpendicular bisector of our segment AB. So then that tells us that the point that's on that perpendicular bisector, so our point C, that it is the same distance to those endpoints. Those two blue lines, so CA is equal to CB. So the distance of CA is equal to the distance of CB. Remember, when you see CA with nothing above it and CB with nothing above it, this means the distance between those 2 points. Next is the converse. Remember, converse, we've mentioned this before, is the exact opposite order of the perpendicular bisector theorem. So this time we are starting if the point is equidistant from the endpoints of the segment. So in our picture, if we can see that DA is the same size, same length as DB, then that means that point B has to be on the perpendicular bisector, even though it doesn't appear that in the picture, but because these two sides are congruent, we know that D has to be on that perpendicular bisector. Now that we've gotten all of our definitions out of the way, we're going to do some practice questions. So this first one I'm going to do, and then you're going to try the next one that's just like it. So if we see that BD is the perpendicular bisector, then that tells us that CB and BA are congruent because it's the midpoint, it bisects that segment, plus we know that the angle right there also has to be perpendicular. And because of that, that means that our point D is the same distance away from the endpoints of those segments. So we know now that 3x plus 14 is equal to 5x. So now it just comes down to solving for x. We can subtract 3x from both sides. Next, we can divide both sides by 2. A lot of the questions you're going to see, you need to take this number and plug it back in. So in this case, we need to find the length of AD over here, which is our 5x. So we need to take our 5x and put our 7 into the x place. This is how I would organize my work, and then I can say that AD is equal to 335. Remember, the AD by itself right here with nothing above it means it's the distance from A to D, which represents our number. Next, I would like you to try this next problem and think through the same process. So you can see that DB is the perpendicular bisector of AC, because you see the perpendicular and the congruent segments for the midpoint. So then that tells you something else. So go ahead, solve for solve for x, and then you want to find the length of the segment AB. So you do need to substitute it back in. All right, now that you're ready to check your answer, what you should have done for each of these is you should have set both of those equal to each other. Then you should have subtracted 3x from both sides. And you can add 1 to both sides. Last, you should have divided by 2. Then, since you want to find the length of AB, we need to put it back into 5x minus 1. So you should have gotten that AB is equal to 14. In this problem, we can see that in our diagram that WX, which is right here, is the perpendicular bisector of YZ. So that tells us some different things. So if it's a perpendicular bisector, we know we have the perpendicular, but it also bisects the segment. And we know that the point W should be the same distance away from the endpoints of that segment. We can also see this 25 up there, so we can see that those two segments are the same size. That means that point B appears also on the perpendicular bisector. So this first question, which segment lengths in the diagram are equal? So we have 3 different sets, and this is what it should be. you should have that yx is equal to xz, then I put yw is equal to wz, and then yv is equal to vz at the very end. So we can see that since yv and vz are equal lengths, we know then that point V is on wx. So yes, V is on wx. So I would like you to try the same question. So you have to do some solving with it, but it's similar to what we did before. But you want to tell me what segment lengths are going to be equal if you see that JK is the perpendicular bisector, and then I want you to find what the length of NK actually is. Alright, so some different lengths that should be equal lengths would be our NJ and JL. Next should be LK and NK. Lastly, we can see that ML is going to be congruent to our MN. We can squeeze 3 lines in there. So to find NK, we need to solve for the x first. So you should set these two parts equal to each other. So 6x minus 5 equals 4x plus 1. And when you solve it, this is what your work should have looked like. So you end up getting x equals 3. So if we want to find the NK, we need to put it back into 6x minus 5. So 6 times 3 is 18, minus 5, and we end up with a 13. Next, we need to explain why is the point M on the line JK, and that is because it is the same distance from the endpoints of the perpendicular bisector that is cutting in half, so that means that M is on that perpendicular bisector. In triangles, when we have these special segments, so a perpendicular bisector, we can have up to 3 in one triangle. So one thing that you will notice is if we draw all 3 perpendicular bisectors, there is a point of concurrency when 3 or more lines, rays, or segments intersect at the same point. So in our picture down below, you can see that all 3 of our blue perpendicular bisectors all intersect at one coordinate, and that's called a concurrency point. The name of it when there are 3 perpendicular bisectors that intersect is called the circumcenter. So almost like the circumference, but it's circumcenter. And that is when the point of concurrency of 3 perpendicular bisectors in a triangle. And it is the equidistant, so the point P here is equidistant from 3 vertices, so the points of our triangle. So you can see in our picture that our point P is the center of the circle that passes through all 3 vertices. So if you see in our picture, there's these blue lines, those are the perpendicular bisectors. Since we know that they are the perpendicular bisectors, I just added some markings into my picture that tell us more about that. And then we can see that the distance from P to A, P to B, and P to C, so the points where they all intersect is at point P. If I connect those to the vertices, all 3 of those red lines actually end up being the exact same length. You can see in my picture now that I drew that all 3 of those red lines are congruent to each other as well. Based on the different types of triangles, so if it's an obtuse, a right triangle, or an acute triangle, the points of concurrency, so where the 3 perpendicular bisectors will meet, will differ from picture to picture of the different types of triangles. So if you can see that an acute triangle, your point of concurrency will intersect at the inside of the circle, and inside of the triangle, sorry. If it's a right triangle, that the points will actually meet right on the edge of the hypotenuse, so the midpoint of the hypotenuse. If it is an obtuse triangle, then the point of concurrency will be outside of the triangle. So sometimes it could be on a different side, but it will definitely be outside the triangle. So in our picture down here, we're going to work through part of this together and part of it on your own. So think of the previous picture that I showed with the blue and the red of what parts are congruent to each other. So if we know it's perpendicular bisectors, if they meet at point G, and those are the dashed lines. So if the dashed lines are the perpendicular bisectors, this is what we will know. So you can see that there are 3 different midpoints, and because of those midpoints, we can add in some other numbers. So the distance from D to B will be a 20. The distance from E to C will also be 15. And the distance from F to C is also 24. The next part that we know is the distance from G to the vertices, and this would be my red lines on there, that all three of those are also going to be congruent. So that means that GB is also 25, and I know that AG is also 25. So this basically answers most of these questions. So go ahead and fill out those 6 answers based on our picture, and then when you're ready to check your answer, go ahead, push play, and we can check out all of them. All right, so the first one is AG, and that's one of those red lines on there, and that's 25. Another one of those red lines was BG, and that was also 25. The next segment is CF, and CF is down there below, and that it was 24. CE was also found by the midpoints, because E is the midpoint of BC, so it is 15. Since point D is the midpoint of AB, we can see that it's also 20 for BD. And AG is a repeat of from before, but if I change that to GE, and you can see in our picture over here on the far right, so GE is this dotted line of my perpendicular bisector. What you will need to use is the fact that this makes a right triangle. And you can see up here in my purple picture that if we have 2 sides in a right triangle, we can use Pythagorean theorem then to find our third side. So if I do that, my 25 squared equals 15 squared plus x squared. 25 squared is 625, and my 15 squared is 225. When I solve then for my x, I end up with a 20. So this means that GE is 20. This is the last problem, and I would like you to use some of the previous problems that we did to answer this question. So if LN is the perpendicular bisector of JK, that tells you some different information, and you need to solve for the x first of all. Once you solve for x, then you can plug the x value back in and find the missing segments. So go ahead, push pause, work it out, and ready to check your answer, go ahead, push play. All right, so your answer for x is 2, and here is the reason why. Because we know that LN is the perpendicular bisector, so that means these 2 segments are congruent to each other because it's bisecting it. And because of that, our point L is going to be the same distance away from J and K. And we can see then that 12x minus 4 equals 6x plus 8. When we solve it, we end up with x equals 2. When you substitute it back into the x value for LJ, we end up with a 20. When we put it back into LK, we also get 20. If you notice, the x is also up there for KP, for the 7x plus 10. When we put it back in there, we get a 24. Because JP is congruent to that segment, then I know that this is also 24. And one other number that we don't have yet is our 12, and we know that point N is the midpoint of JK, so NK also has to be 12. So then, when we answer the questions, these are the 4 answers you should have gotten. To tell if point P is on LN, so if point P is on the perpendicular bisector, we have to know that they are the same distance away. Your point P has to be the same distance away from those 2 endpoints, so to J and K, and they are the same distance, they're congruent, plus we plugged it back in, so we get 24 for both of them. So yes, P is on LN.